The quantum computer that would break our cryptography today does not exist yet, but it is coming closer paper by paper and engineering hour by engineering hour. People are scaling how big quantum computers can be and are also making it easier for a quantum computer to break our cryptography. Today we know that an algorithm that could break the way how we secure our transactions and data exists. The computer doesn't yet. We don't know if that computer will ever be built, but there is a good likelihood that it might. And at that point, data that have been encrypted in the last 10, 20, how many years could all be decrypted at some cost. So there are two proposed solutions on how to continue securing our data once a cryptographically relevant quantum computer is built. For some applications, there is quantum cryptography, or how do you protect data using physics. Still, it does not solve the whole equation. You still need to combine quantum key distribution with classical cryptography of some sorts. So you will still be using cryptography in the end. However, there is also a new kind of mathematics, if you wish. Post-quantum cryptography uses different kind of mathematics for which the scientists do not know how to make a quantum computer that would break it. So this gives us some breathing room. By using this new kind of cryptography based on different mathematics that the quantum computer can't break, that we currently know of, then we could move all our systems to this new kind of cryptography and keep them secure. So now when we've established that organizations have to do something, then the question is what it is that you have to do. Well, first of all, if you're using a computer today, then it's highly likely that cryptography is being used somewhere there. If you're using any sort of communications on the internet, for example, then you are using cryptography. Now, the good news is that for many applications, it's not up to you to actually do much. If you're using an app, if you're using a website, if you're using a modern computer or a smartphone with a browser or something like that, a piece of software, then the vendor of that software will likely transition to post-quantum cryptography for you. You just need to make sure that you run all the software updates. Things get more complicated if you make software yourself or if you are buying bespoke software. In that case, you need to start thinking on how does that software transition to this new kind of cryptography that would be safe to a quantum computer. That means that you need to first of all decide who will lead the effort and then give them the resources that they need to go forth. Sometimes it can be something simple, just updating the platform in your software. Maybe it's a Java version, maybe it's something different. In other cases, you might actually have to buy some new hardware. The good news is that post-quantum cryptography is still software. You don't desperately need new computers to use this new kind of cryptography. Indeed, Cybernetica has spent almost the last 9 years figuring out how to start using post-quantum cryptography in our systems. We started working on that because cryptography is our core. We've been building cryptographic systems for nearly 30 years now. We saw that the time will come when all the systems that we have built to all the countries, to all the industries, to any organization, that we will need to transition them. So we started preparing early, and today we have roadmaps in place. The products, the technologies we make, we know how to transition them. So if you have been working with us, then we will have a solution for you in time. Estonia is a pioneer in e-government, and information security has been a foundation for that e-government. Estonia is in a very complicated place with all its cryptography. We have deployed a lot of it. We have deployed the kind of cryptography that not all countries are yet using in production. That's why we have all these digital identity services. That's how we can have internet voting in place. However, that also means that there is more for us to do. We need to figure out how do we transition all these complex cryptographic systems to post-quantum cryptography. We have started the research years ago. We have started publishing the papers, and this year, in 2026, we have completed the roadmap for the Estonian government on how to transition to post-quantum cryptography. Some pieces are simple. Update software here, change a configuration line there. For other things, more research is still needed. And here we are performing that research at Cybernetica.